surrounding model states. So mostly it'll be Matt speaking, with me butting in every now and then.
Yeah, we'll give you something to look at. A little bit more interesting than just a static slide. I'll be honest with you, this is from Autodesk, so it just gives a couple of quick examples of what model states can do. And I'm not going to try and keep up with it. In fact, I'm not even going to look at it while I'm talking because it will only distract me. So what is model states? Model states is the new technology in Inventor for 2022. Technologically wise, it's the biggest change in Inventor since year dot, the biggest underlying code change that they've ever had. So this is fairly important. It was doing the rounds 2 or 3 years ago. It's taken them a couple of 3 years to get this right. I think they would like to have introduced it in Inventor 2021. Who knows? Maybe even 2020.
I know it's been in beta for a couple of releases previous, hasn't it?
And they've done the right thing. They've said, you know what, we can improve this, or we've found a little bit of a problem here and there. Let's take a step back. Let's fix it. Let's polish it. And let's release it in a better state.
Yeah, aye.
There's no point rushing it when it is such a big underlying change to the software. It was introduced to fill some holes, solve some problems. One of the big things is it's a replacement for level of details. Level of detail does not exist in Inventor 2022. Level of detail has its place. It had its place 10, 15, I don't know, 20 years ago. We're all driving around in 2 gig 32-bit computers, and if you're building the entire factory, you are going to run out of space. There's not enough memory on that machine to run Windows and Inventor and Excel and everything else that you're driving, then open up a 5 gigabyte super assembler. There's just not enough oomph on that machine. Level of details, if you're working on the factory and you're in the office, there's no point loading the shop floor. If you're working under the hood of the car, what's the point in loading the boot? If you can't load the entire thing, you load the bit that you're working on, a reduced level of detail. That's the kicker. A level of detail was a performance tool. A, it takes too long to open the entire model, or B, you cannot open the entire model. But unfortunately, a lot of people were using level of details for configuration tools. Give me a variation of the machine that's got the touchscreen interface, and give me the variant of the machine that doesn't have the touchscreen interface.
Right, so using the whole variant of the theme concept.
Yes.
Right, understood. Okay.
Level of detail, suppress some components, swap some things in and out. And if it did work, you could argue it was more accident than design. Autodesk have been well within their rights to change their software. And if it carried on working as it was designed to do, that's fine. But if you were using it not as it was designed, if things started changing and didn't work as expected, unfortunately, that could cause a problem. And now Autodesk are aware of this. They don't want you to use level of details for configuration reasons, but people do. So that's one of the benefits of model states. It replaces level of detail and it kills multiple birds with one stone. It does give you configurations so that you can open the machine that's got the touchscreen interface, or the version that's got the dials, or the version that's got, you know, a piece of string and a hammer. It also gives you the performance. You can use shrink wraps. You can use substitute level of detail effectively. You can remove the entire internal combustion engine with 100,000 extra components and swap it out for just one big footprint block, X, Y, and Z cube of the right size. So it gives you the same functionality as level of details, and it gives you the functionality of level of details that they were being used for, configurations and performance. It's not a replacement for iParts and iAssemblies. They will still exist. There are probably millions of iParts and iAssemblies out in the wide world, and that technology is not being removed. Obviously, I can't speak for Inventor 23 or Inventor 33 or Inventor 43. Don't know what's going to happen in the future, but I suspect, like with joints, they brought in a new concept, a new technology.
Yep.
They didn't remove the old technology. Constraints are still there.
Yep.
So the two work hand in hand. with model states, iParts, iAssemblies, they all have their place.
Yeah.
If you were starting a company from fresh and you had 0 files and you were starting day one, I'd say start with model states. They're just a little bit easier. They're a bit easy to manage. But if you've got 20 years worth of iParts and iAssemblies, by all means carry on using those, but still investigate and look into model states to see what benefits you've got.
Are they an evolution then of iParts and iAssemblies, or is it a new technology?
It's a new technology.
Right.
They are completely different. They're not migratable. There's no mechanism to click a button on an iPart and have it automatically converted into a model state. You could probably do a bit of copying and pasting within the Excel spreadsheet when editing the table and copy the values over, but it's something that you do manually. They're not intending to replace iParts, iAssemblies. Right. This is in addition to, or you might use it instead of, but the technology will still be there in the background.
So in 2022, you've got iParts still, you've got iAssemblies, and you've also got
model states. You've got 3 things now that you can
learn something new every day. I didn't know. I thought it replaced it, so that's good to know.
The only thing that it does replace is level of detail. That does not exist in Inventor 2022. Right. Level of detail benefits have been slowly being removed and become not needed over a number of years of Inventor, but finally they've put a stop to that.
Any of these on the rolling slide here, Matt, that you want to pick up on, or do you want to jump on to the next one?
I'll just have to have a look at the slide now to remind me of everything that's in it. To be fair,
I've thrown him there.
He has thrown me. It's a number of configurations. It's a number of manufacturing stages. So to be fair, I will step through these on various different static slides.
Right, fair enough.
As I work my way through. So I think now's as good a time as any to start with that. So there's one slide. We've got a couple of examples. These are manufacturing states. So different people need different information depending on what they're doing within the business. So looking at the 4 blue components at the top, some sort of end for a hydraulic system. The top left image is the cast model, lumber cast iron. That's the drawing that the foundry need. Yeah. The foundry doesn't care about the sizes of the holes. He just needs to know the size of the mold. By building this as a model state, the master file is the top left one. And then you add progressively, in this case, additional features. Some very thin extrusions, top right image there.
So that'll be that for the machinist, for example. Exactly. Representation for the machinist.
Yeah, just flattening off subsurfaces. Yeah. Then we take it over to the machine shop who then bore it out, do a bit of drilling and tapping. And the bottom right image, we've got some champers on there. The shop floor that actually placed this component on the machine, they're interested in the bottom right image. Right. The fellow that makes it from a lump of solid steel, he's interested in the top left image.
So the boring guy needs to see the one on the bottom left.
That's it. Absolutely.
Right. Sorry, I just had to throw that one in.
That's fine. Right. So you'd have one drawing with 4 views of the same component in different states. So you could have 4 separate drawings. Point is, you've got one file that holds all the information. Along the bottom there with this arm, again, it's a similar exercise. You've got the cast unmachined component on the left. In the middle, it's bored out, and then on the right hand side we're finishing it off by machining some surfaces, and again it's all managed within the one file. The one file is something that we'll come back to in a couple of slides time. That's a big change, a big difference between iParts and iAssemblies. So that was manufacturing stages.
Right. Yep.
This is configurations. So same component doing different jobs. So a simple sheet metal bracket there. And as you can see, we've either got 1 flange or we've got 3 flanges on it. All we're doing with the model state is selecting a feature or a component and suppressing it, turning it off. Well, then that state is remembered in the spreadsheet in the background, and then you can flick them on and off as you want. As well as turning stuff off in the part level, we can turn components off at the assembly level. So the bottom set of images there, some form of hydraulic pneumatic actuator, and we can see that they've got 2 different ends, all self-contained. So we've only got to build one master actuator, and then it can be umpteen different flavors. And again, it's all about the management of the files. Everything's in one place, everything's convenient. If you can drive an iPart, if you can drive an iAssembly, if that's something that you've been doing for 3 weeks or for 30 years, then driving model states is going to be no problem whatsoever. Technologically speaking, No, wrong word. I don't know what word I'm looking for, but the actual act of doing it is virtually the same.
Practically.
In practical, yeah, practically, it's virtually the same. The
You
technology is different, but the practicalities of it, if you can do one, you can do the other.
Rightio.
Right. Now, there's our number of files. With an iPart, you've got the master, the factory, the parent iPart that contains the spreadsheet. And in this particular case, that particular iPart can generate 36 different sizes.
So there's 37 in total.
There's 37 files that you potentially have to manage on your hard drive,
right,
or through Vault.
Yeah.
But there's 37 things: the parent file and all the children, the factory and all 36 products of that factory. Granted, if you only use one size of that Vault and 35 sizes just never get used, you've only got 2 files in your hard drive. But anytime you use one of those iPart children, you get another file on the hard drive that's got to be managed.
Right.
As an individual driving the system, you only ever place Bolt iPart factory and you pick from a list. You place Bolt iPart factory, you pick from a list. You don't know that all these files are being created in the background, but the fact that they are being created means something's got to manage them.
Yeah.
So Vault will look after them, Inventor will look after them, but you've got more stuff on your hard drive to deal with. Converting or creating this as a model state, I shouldn't say converting because you can't convert an iPart to a model state. There's no built-in mechanism. Creating a model state of this Bolt, there would be one file on the hard drive. That one file can be large or small, long or fat or tall or thin, it doesn't matter. You can place 36 occurrences of that single IPT in your assembly, and each one can be set to a different size. You've still only got one file on the hard drive. So management-wise, I think it's going a long way. There are some, shall we say, considerations at the Vault end. Now, we'll come back to this at the end of the live demo. This isn't a Vault training course, again, this is, but I'll do a bit more spiel on this in Vault, but there are considerations.
Yeah.
You might find that iParts are still the way to go, depending on your flavour of Vault, depending on your requirements. But there are a small consideration as far as model states and Vault is concerned. Right, moving away from stock images, now on to real images. Couple of 3 slides here explaining what happens, and I can show you this live in Inventor as well. But this is a level of detail based Vice assembly in Inventor 2021.
So this is as was.
This is as was, yes. Right. Level of detail folder is there. It contains some stuff, and obviously I've created a couple of 3 at the bottom. Level of detail, no bolts, no plate bolts, no base bolts. So all my bolts have been suppressed. So in the CAD model, they don't exist, either because I'm using it as configurations, which I shouldn't, and I don't need those components, or because I'm using it for a performance tool. Those extra 4 components were the straw that broke the camel's back. I just couldn't quite open this huge, great assembly file with those bits loaded, but in reality, I don't need to see them anyway, because they're nuts and bolts, the content center. The small things. Sweat the big stuff, don't sweat the small stuff. But what you can see in the bill of materials there is even though the components are suppressed, the bill of materials still shows them. They still exist. So that's where the configuration element of level of details kind of fell over, because the bill of materials was never fully in tune with the configuration side of LODs. So that's where people potentially trip themselves up. A lot of people are still using it and they're working around it. That might be the data that you want. You might need to change the data, but it's something that people have been doing for 10, 15, 20 years.
Yeah.
So, you know, they've worked out what's required for them. Now, when I open this in Inventor 2022, which is that screen, the level of details are automatically converted into model states. You'll notice there is no level of detail folder. Under
just flick back to the last one.
So you've got we've got representations, you've got views, positions, level of details.
Yeah.
And in 2022, you've then got a specific model state folder. Unfortunately, on this particular screenshot, my representations folder wasn't expanded, but I can show you that live in Inventor.
Yeah.
The level of details folder element isn't there. We still have design views, which is looking after component visibility, component color and camera, spinning the model, making something invisible, so parts omitted for clarity. Still exists, but I need to see through the door to see what's on the inside of the cupboard.
Okay.
Camera position, colour. We only modelled the bolt once, but you could have a green bolt, a red bolt, and a blue bolt in the assembly. And positional representations as well, which is a mechanism for capturing constraint states, so that you could have your robot arm fully extended or fully contracted. You could have the gripper open or the gripper closed. And then rather than going through and editing 15 different constraints to put it into multiple different positions, you could just quickly activate the closed positional rep or the open. And again, model states will look after constraints. They'll put things in different positions, but they're not a replacement for positional representations. Your overlay view on a drawing,
yes,
where you can have two positional representations on top of each other, one of them drawn in dotted, so you can see the minimum and the maximum extension of something.
Yeah,
that doesn't work as a model state, but does work as a positional representation. Slightly digressed. The converted level of detail that's made automatically into a model state still shows the bill of material as you would see it in 2021. So it still tells me that I need four, oh, too soon. I need four nuts and bolts.
Right.
Even though they're potentially been removed, it would always tell me. In fact, when I was taking this screenshot, I had the no bolts level of detail active, and the act of turning on the bill of materials flicked me over to the master file. So it will always show you the latest information. This is what's known as a delegated BOM. Basically, they are cheating the BOM to make it look like what it did in the level of detail world, so that you've at least got the same information today as what you had yesterday. Rightly or wrongly, the information's there. If we were to create a model state from scratch, or in this case, right click on an existing converted level of detail model state and copy it, because it's created in this session of Inventor, in this version of Inventor, it's not converted from a previous one. In this case, level of detail, no bolts, 1. You can see now I've highlighted that the number of bolts is the quantity set to 0. So if you make your own model state, rather than having Inventor convert a level of detail for you, it will give it you as a configuration. Genuinely, in this case, there are no bolts, so the quantity of 0.
Yeah, because that's purchasable. Right.
Rather than telling you 4 would be required for all different combinations, not the one that you're currently looking at.
Yeah.
There is some talk, as I've heard, and I think I agree, that I don't want that row to be displayed. If it's 0, I'm only turning off 2 components here, but it could be I'm turning off 99 out of 100 components, depending on the combinations. I'm going to get a lot of bill of material that's got 0 quantity. There are ways around this. You can hide on the parts list. Look, you do it manually, use a bit of iLogic. You can find all the quantity 0 rows in the parts list and set the visibility to off. You could, in the bill of materials, maybe change it to a reference component. A reference component doesn't show up on the BOM. A little bit of a jiggery pokery there. You'd have to unsuppress the components at the bottom left-hand corner of the browser, set them to reference, and then resuppress them. But that reference state would then be recorded within the model state, so that as you're flicking between unsuppressed visible, there would be a normal component, suppressed will become reference, so that they would appear and disappear from the BOM as and when required.
Right.
There's no single button, there's no tick box that says hide 0 quantity, but there are mechanisms that you can put in place. There are strategies you can use to give you a cleaner, shall we say, shorter bill of material. Right, I'm going to jump into live Inventor now.
Yeah.
Right, okay. There we go. Level of detail.
This is advice. There we go.
This is advice. Level of detail, automatically converted for model states. There is no level of detail folder anymore. Everybody's happy. If I activate a particular model state, we can see that the bolts get suppressed. Everybody's happy. But if we look at the bill of materials, we get a dialog box stating that we're looking at a delegated BOM. Basically, a fake bill of materials has been created to give you the same information as what you were expecting to see from the previous version of Inventor. And to do this, it's going to load up the master model state, and it'll show me that I need 4 bolts and 4 screws.
Mhm.
Now, if I create a true model state, I can create one from scratch, right click new, or I can take an existing one and copy it. Dead simple, right click copy. Because this new model state was created, shall we say, live and in this session of Inventor, the bill of materials will reference that model state as we see it. And we can see there that it's now set up as 0 quantities of both those nuts, those bolts and those screws. So this is now giving me information as I would expect to see it. As I would expect to see it for this individual configuration, as opposed to the information I need to make any configuration of this thing.
Mm.
Right. Just for the sake of consistency,
Yeah.
I have, there's one I prepared earlier, another file.
For the benefit of those at home.
Yes, it's a vice, dead simple. As you can see here, I've already built a number of different model states into this vice. The process is quite easy. Makes sense. This is the way I've done it. I've started from the ground up, taking the lowest level, let's call it the equivalent of an I part.
Yeah.
So this is a standard part file. Model states, all we've got to do there is create a new state. Effectively, it's similar to a copy of the master state there. With that one activated, I can then make any change I need to. So let's just make a long component, and I can't see my screen because I'm in Zoom stuff. There we go. Finish the sketch. So now we've got the model. This one's going to be extra long. So creating them is dead easy. And we can see there that those values within the sketch are then held within the file. Just like you do with an iPart, iAssembly, you can edit this via spreadsheet. So once you've created an example of the thing, once you've decided to start driving a particular value parameter, you could then use your spreadsheet to drop in all the different configurations.
Right.
It might be easier to build the spreadsheet, copy and paste, etc., than it would be to build individual lengths. One little bit of warning, if anybody out there is an iPart iAssembly user, factory scope and member scope. When you're on member scope, any edits you make to this particular occurrence don't occur to the others, so that you can create unique features on this occurrence that don't occur everywhere. If I need a chamfer on the edge of that hole everywhere, I'll use factory scope.
Right.
So, oh, raised hands again, sorry.
Oh, sorry. Yeah, so it was the spreadsheet, because we're sharing that particular program, so they didn't see the Excel spreadsheet.
Yes.
But it's just a basic table showing the iteration levels with some dimension figures in there. That was all. Nothing.
We're not
nothing
trying to hide.
fancy. Just a very 2-second spreadsheet.
Yeah.
That's all that was.
Member scope, sorry, factory scope. If I put a chamfer on that edge, every size of this component will have a chamfer on the edge. Member scope, if I had the chamfer on this component, which is currently set to, let's say, short, it wouldn't exist on the medium and the long version. With an iPart and an iAssembly, if you delete a feature with Inventor 21 or prior, it actually suppresses it if you're on member scope. New to 2022, which is probably Autodesk making it work like it should have done, but it will change everybody's muscle memory. If you delete a component or a feature, it gets deleted. It deletes it across the board. So a little bit of a gotcha on that one. My muscle memory says if I'm on member scope, I can delete a feature and all it will do is suppress it for this row. But going forward, if you delete a feature, it will delete it properly. So I've got a couple of sizes in there. Then at the higher level, which is the assembly, again, we've got the model states then built into the assembly file. And all we're doing at this level is selecting the relevant lower level model state. So now that I've added in the extra long variant of this thing, I'm going to take the, what have we got, the long ball, I'm going to copy that one. quick rename, extra long. There we go. And with that one activated, I've spelled it wrong, but I'm not going to get too hung up on that. I can then activate the longer version down there. So you're combining the different model states together.
All right.
So I start at the part level, the equivalent of iParts, move up to the assembly level, the equivalent of iAssemblies. And by the time you then get all the way back to the top, you've then got a series of model states that you can work your way through. So short version closed, medium, long, not terribly exciting, I grant you. But we've got, I'm swapping out, for example, I'm excluding the ball on the end of the handle and swapping it out for a stud.
Right.
So you can, as well as changing component sizes, you can include, exclude components and swap them out as on a case-by-case basis. So 3 different sizes there. I've also included the fact that we can capture the constraint value. It's akin to a positional representation. So I can have the model open or the model closed, but it is not a replacement for positional representation.
Right.
By virtue of the fact you don't get your overlay views and such like. So use that knowledge as you deem fit. Now, once you've created all of this, the end game is to get a drawing.
Naturally.
So I've got my workbench. Onto that workbench, I've placed the same vice 3 times. But this vice can then be set to be whichever model state is required. And it actually tells me there in the extended name within the browser which variant I'm looking at any particular time. And again, I can just double click and swap it out and chop and change. Thing is, I don't have 3 vices on the hard drive. I've only got 1 vice assembly. I've only got 1 screw thread, not 4. With all the different combinations of open and closed, long and medium and short, I would have, the math escapes me, but I'd have at least that many files sat on the hard drive.
Many.
Let's leave it at that. Times also by the different combinations of sub-assemblies and subparts, etc.
Right.
I'm saving myself quite a few files on the hard drive. That's the takeaway from this. The other nice thing as well, new to Inventor 22, isn't model states. It's just another new feature, but works really well with model states, is instance properties. If I right click on a feature, on a component, I should say, and this is not unique to 2022, I can look at the iProperties of something and I can set my title and my description, my part number, my stock number, and as many custom iProperties as I wish.
Yeah.
But that value is then the same for every variant of that part. Anywhere that part or that assembly is used, it will have the same title, it will have the same description, because it's unique to the file. And every time you use the file, you get the same information.
Right, because it's fed off the same base metadata, it copies.
Exactly.
Right.
But the fact that I'm using the same file 3 times, they're not the same title. One's long, one's medium, one's short.
Yeah.
So Autodesk have brought in at the same time, thankfully, instance properties. With instance properties, it's effectively custom properties on a case by case. So there I've called it title, and this one's called short vice. This one, remember, it's the same file, same component on the hard drive, but as far as this assembly, this overall bench assembly is concerned, it's got a different value.
Right.
So the instance properties are held within the assembly where you set those instance properties. In another assembly, that one wouldn't necessarily be short vice as a custom property. I could set that information up in the model states, because model states will drive features, they'll drive components, they'll drive iProperties. So in reality, I'd probably set the iProperty within the model state to be short, medium, and long. Then I wouldn't have to populate it every time I use it. But I didn't do it in this particular case because it gave me an excuse to show you the case-by-case option. You might have a single vice. It could be a mortar. It could be a standard mortar of a standard wattage. I'm not an electrician, so I don't know the right terminology. But depending on what that mortar does, and it's used multiple times throughout the factory, you might need to call it out under different names. One motor's for the pump, one motor's for the winch, one motor's for the ABC, XYZ.
Right, sure.
Same component bought from the same RS catalogue page with the same part number, but you need to refer to it doing different jobs within your overall general arrangement.
Okay.
So just finishing off, ties in with that, because you can then pull in your instance properties, excuse me, from your drawing, your components, as opposed to general I properties and whatever.
Yeah.
We can then point it out on screen, just as we've done there.
Okie dokie.
Um,
It's a live environment bit.
okay, so I'm now going to go back to the PowerPoint.
That's the
There
one.
we go.
So we should be in PowerPoint land
Yeah.
now. If not, raise your hand. Thanks for those that did before.
Yeah. Volt, something to appreciate. Play on words, because you should be using Volt.
And you should
appreciate it.
Volt.
Absolutely.
Yeah,
when you're putting I parts and I assemblies into Volt, because it creates a unique file per configuration on the hard drive, that Volt creates 36 children files on the hard drive.
Yeah.
When you use one of those files in your assembly and check the file into Volt, Volt knows that you need a long screw or a short screw. It knows you need a big washer or a small washer. It knows which size are used because you're using specifically an individual file. So as Volt Basic all the way up to Volt Pro, it says I need M10 by 50 bolt, and I also need an M10 by 60 bolt. Volt Basic will tell you which file you need, but not the quantity. Volt Professional, through the item master, can tell you the quantities of files that are required.
Right, so it's the item master.
Yes, it's the item master that gives you the quantities, not just the file in question.
Right.
When you put model states into Volt, there is only one file. So the M10 by 60 and the M10 by 50, they're not two different files. So Volt Basic will just say, I need whatever the file was set as master, an M10 by 50. It'll tell you the file that you need to make sure that you've got the IPT sat in your hard drive ready to be used.
But not the instance of that file.
But not the instance of that file, exactly. Right. The assembly that you open in Inventor knows which instance to use, which row in the spreadsheet, but Volt doesn't, Volt Basic doesn't. When we go in the Volt Pro world, because we can itemize stuff, and that's how we build the bill of materials, which gives us the quantities, Volt Pro is capable of pulling out the relevant bit of information. Right. As a vice checked into Volt and itemized, the bill of materials tells me down here that I need 4 bolts and 4 screws. The plate screws and the base bolts.
Right.
What that's telling me is to build any or all configurations of the vice assembly, I'll need 4 bolts of this type and 4 bolts of that type. Whether I end up using them or not is irrelevant. But that gives me the information. That's all possible combinations, configurations of that assembly. That's the stuff I will need. I'll end up with some spares. I'll end up with some unused stuff when I'm talking purely at the vice level. But if I add that vice to a higher level assembly, I actually use the vice on the workbench and then put the workbench into Volt and itemize the workbench. The workbench is aware of which vice I'm using. It knows whether I'm using the long one or the short one. It knows whether I'm using the one with the bolts or the one without the bolts. So you see the level up there, vice positional rep. That's just the standalone assembly, all possible combinations. I need 4 screws and 4 bolts. But if I add it to a higher level assembly, the higher level assembly is then aware of which model state instance I'm using. And you can see at the bottom, I only need 4 bolts. So the 4 screws that I have been suppressed through the model state technology no longer show up.
Right.
Volt Basic will tell you which file you need, just not which variant of that file, which configuration of that file. Volt Pro will tell you which file you need, just as file management. But if you do itemize it, it will then pull out the right numbers.
Right.
If you itemize it as part of a higher level assembly.